So what I'm going to talk about in this video is something I want to call model visualization. So when you're given any given assignment, so say like this assignment, and you're asked to model this three-dimensional object based on these dimensions given, the first thing you should try to do is visualize how you're going to construct this model. You got to remember that you're not trying to draw this model on two-dimensional paper, you're trying to model this in a three-dimensional space using the tools that you know in that modeling program. So in SolidWorks, your basic tools to add material are extrude boss base, revolve boss base, sweeps, lofts, and that's about it. And then your tools to remove material are extrude cut, revolve cut. You can do fillets, you can do chamfers, you can also do a swept cut and a lofted cut when we get to that point of learning that. So for right now, if I see this, the way that I visualize how to model that, this is obviously my finished model. The way that I see it is broken down into these 5 steps. And there's many different ways to model this. Some are more efficient than others, but in the end there's many different ways. You can get to the final shape by many different methods. The challenge is finding the easiest and fastest way, right? Because as engineers you want to be efficient. So if I take my mouse and I grab this blue line right here, you see that little hand pops up, I can drag this up and I can see, I lost my model, but it's still there, everything's just suppressed. So if I can drag this down, I can see that this was my first feature that I created to make this model. General outline, I extruded up the entire height, so here you can see this is the sketch that I used, fully defined, and I extruded up. If I edit feature, I can see a distance of 2 inches. So looking at this, I extruded up the entire distance and I sketched this general profile of the entire part. The next thing I did is I did an extrude cut. So I sketched on this side surface and then I extrude cut through the entire part. So you can see I built the fillet into this sketch, essentially eliminating the need for a feature fillet because I'm trying to simplify my model tree. So that was the second step. Third step is you cut the slot, so another fully defined sketch using the tools I know, extrude cut. The fourth step was this hole up here. And so you should notice that I could have included this hole in my first feature and everything would have came out identical. So like, for example, let's delete that feature. Now I no longer have the hole. I'm deleting the sketch that feature is made from. So I'm missing the hole here. If I go back into my original sketch and I draw a circle at that point, let's put a dimension on this, then I accept that, I get to the same end result that I was with that additional feature. So anyways, many different ways to do it. I always strive to do the most efficient way of modeling. The next step is the hole wizard for that final hole. So you can kind of see step by step how to model this. Step 1, step 2, step 3, and step 4. Let's look at a different problem, which would be this, and you should see this later on in the quarter. This is a more complicated part. Obviously, there's kind of a lot of features going on, but if you look at it, you only got 5 steps, 5 features. So here is the problem statement. So the question you should ask yourself when you see a problem statement like this is, how am I going to model this? Looking at this, the first thing that I recognize is that I have a constant cross-section going through the entire part, which tells me that I could create a single sketch, shown here, and I could extrude that by the full length of the part, and then I can get most of my features in one sketch. Like that's pretty good. I could have just extruded a rectangle, and then I could have done an extrude cut for this little slot. I could have done an extrude cut for this. I could have done an extrude cut for this big hole, but that would have been many more features. Again, I'm trying to limit the amount of features. The next step, if I roll down my feature tree, is the cut extrude for this X feature right here. So I'll show you the sketch plane where that was created from. Again, a single sketch, extrude cut by a specified depth of 1.5 millimeters, which if I look on my problem statement, that's that number right there. Okay, my third step is the hole in the top. So this hole is its own feature. This little tiny hole has to be its own separate feature. I use the hole wizard for this. I could have done this with a cut extrude on a simple circle. It doesn't necessarily matter how you get there. Next step is this little groove. So if I look from the side view, you can kind of see there's a groove in there. On the problem statement, that groove is defined here. And this is done with an extrude cut. And something to notice is my sketch plane, I sketched on this surface. That's my sketch plane. And if I look at my feature is extruded offset from that sketch plane. So this is my sketch plane right here. And I extruded offset and I came back a distance of 1.5 millimeter. If I want to flip the direction of this arrow, which way it's extrude cutting, I can hit this little flip arrow right here. So that's my first groove. The second groove is identical to the first groove, it just has a different location. So what I did in this is I took the same exact sketch. Notice that both of these features are based on sketch 6. And instead of extrude cutting offset by the first distance, I did a 56 millimeter offset, and then I extrude cut a direction of 1.5 in this direction to get to my final shape. So again, looking at this, we have 5 features. So a relatively complex part is made in 5 features. First extrude, second extrude cut, we got the hole wizard feature, another cut extrude for the first groove, another cut extrude for the second groove, and that's it. Thanks for watching.